So we have a surface on which, and we have a spring, and we have a mass that's x equal to 0, and we pull it out to some position x equals 3 centimeters. So we pull it out up to here, and then we let it go. The mass is 0.5 kilograms, and the spring constant is 20 newtons per meter. And we would like to find a number of things, so we'll write them as we go along. So in order to solve it, the first thing we do is we say omega, which is k over m square root, would be 20 over 0.5, which is the square root of 40, which we can write as 6.325. So that's the value of k, that's the value of omega, which would be radians per second. And now we want to find the first thing, which is V max. So what is the velocity when it's crossing this point? That is going to be V max. And we can use the equation that we just saw, that V max would be square root k over m a square minus x square. So for V max, x is 0, so it's going to be k over m a square, and that becomes omega a. Well, it's plus minus, so it's negative while going to the left and positive while going to the right. And we can substitute these numbers right here. Omega is 6.325. Let's just take the positive, take the magnitude, and our x, because it's a is 3 centimeters, so 0.03 meters, and that comes out to 0.1897 or 0.190 meters per second. So that's the speed with which it crosses the middle. Now the next thing we'll find is A max. What is the maximum acceleration, which will be here and when it's at the other extreme. And for acceleration we have omega square a, so that's going to be omega square will be 40 times a is going to be 0.3, so that will come out to be 1.20 meters per second square. So that will be the maximum acceleration. Now let's say we want to find the velocity at x equals 2 centimeters. So as it's going here, this is 1 centimeter, 2 and 3. So what is the speed when it's crossing this point? You can solve it for any other point too. So we use this equation. It's k over m a square minus x square square root, again plus minus, because at this point it will be going this way, and then when it's going back it will again cross that point and going to the right. The speed at both points, the speed at that point will be the same in both directions. So k over m is 40 and a is 0.03 square and x is 2 centimeters, 0.02 square. Take care that you don't take a minus x whole square. This is a square minus x square, and when we solve that we get 0.1414, which we round to 0.141, and that's the speed, so meters per second. So at this point it has 0.14, and becomes 0.19. Now the kinetic energy, let's find next thing, that is the kinetic energy at 2 centimeters. So for that we can simply use half mv square, which will be half, and the mass was 0.5 kilograms, and v would be 0.1414 square, and this comes out to 4.998 into 10 to the power minus 3, which we can write as 5 millijoules. Now the potential energy at the same point will be half kx square. That's half, and the k is 20 newtons per meter, and the x is 0.02 because we're finding it here, square, and this comes out to 0.004 joules, which is 4 millijoule, and the two should add up to 9 millijoules. Now let's see whether it does. So if we find the E, which is the potential energy at that point, which is the total energy, half Ka square, that's going to be 20, and the A is 0.03 square, and we've saw that it comes out to 0.009 joules, which is 9 millijoules. So same as what we got from here. So that is the total energy. Now if we want to find it at, that's minus 3 centimeters, that's minus 2 centimeters. If you want to find it here, the values will all be exactly the same. The potential energy and kinetic energy will be exactly the same. The velocity will be the negative of this value, and that's the only difference. And the Vmax, well, that would be here. When it's going the other way, would have a different sign. So it could be a plus or a minus depending on which way it's going. So it should have a plus or a minus here too. Whenever we take the square root, should have a plus and minus. Okay.